Hello, folks. Very nice to be with you, and thank you very much for the introduction there. I'm doing less Java now than I used to, as now I'm working at Google on .NET client libraries. I actually don't do very much Java anymore, so I'm sort of a few years behind. But still, there are plenty of questions that I'm still able to answer, mostly on dates and times, which is our topic for today. So I've called this "Working with Time is Possible." Until this morning, the slide did just say easy, and it's really not easy, but it is feasible. And this is the main takeaway for today: is next time you end up with something in your code that needs to work with dates and times, don't be afraid of it. Don't think it's going to be absolutely trivial. You need to take some time, work out the requirements in detail, and eventually things will make sense, I promise. So if you take away that message and one other later on, which is to inject a clock, I'll go into more detail later on. Everything else is just sort of a few details to help inspire you for when you do the extra research. I tend to think that talks like this, you won't absorb everything I've got to say, and that's absolutely fine. Hopefully, what I'm persuading you of is the need to go away and do some more research for yourself and tackle this this topic properly in your own code. So the things we're going to look at today, this introduction and what we're talking about and what we're not talking about. Then I will go through a huge list of concepts. You'll see that list in a minute, and your immediate reaction may well be, that's just too many. I'll explain why it makes sense to have that many concepts. Then we'll talk a little bit about how to use them and a few tips, tricks, things not to do, things like that. Along the way, we may have some trivia. That tends to depend on the day and what my memory is like at the time. I will bring up my Noda Time trivia page in the background. If you want to look at all the trivia that I'm aware of, if you go to the Noda Time website, which is just nodatime.org, there is a page there of trivia and all kinds of weird and wonderful things, mostly around calendar systems and time zones. But it's a really interesting topic, and one that is more culture-based than almost anything else in computing. So what we're not looking at today is relativity and leap seconds. So relativity, things going very, very, very fast, and they experience time differently to other things. So if you've got the idea of an astronaut who accelerates massively and then comes back and is younger than their twin brother or whatever, we're not going into that. It makes my head hurt too much, and it almost certainly isn't relevant to your code. I really hope not. I also hope that leap seconds aren't relevant to your code. So the point of leap seconds is that the rotation of the Earth isn't precisely 24 hours. And as the Earth's rotation changes slightly, we end up slightly off from where we should be. And leap seconds are inserted every so often to try to mitigate that, try to correct things. That won't actually be the case for won't be relevant to almost any code if you are writing something like a GPS system, where the absolutely precise instant in time is really, really important. Then it's important, but most of us can just ignore it and assume that every minute has 60 seconds, because a leap second is inserted so that a minute around the start of July or the start of January can have 61, or I think in theory even 62 seconds. Most things, most operating systems, programming languages, libraries, etc. hide this, and you will never need to know. If you're just writing business software, chances are you won't need to know. If you do need to know, hopefully you will already know more about this than I do, and it'll be fine. But we're not going to talk about it today. So just to give a bit of a background as to why I talk about this, and I apologize that some of the time my face will be massively in the light. I'm sitting in my shed at home, and the light is streaming in through a window in front of me, and there's not a lot I can do about that. Hopefully it's not too distracting. However, the reason for talking to you today about dates and times is that developers typically have one of two reactions to dates and times. If you are relatively new, relatively junior, and to be really, really clear, there is nothing wrong with that at all. I'm all for junior developers learning more. It's all great. And I sort of envy you the vast domain of things you can learn about and explore, and it's great. However, a lot of junior developers, having not been bitten by the problems of date and time, think it's easy. And some libraries, so the .NET standard library with datetime, for example, makes it look quite easy by ignoring all the complex things. On the other scale of things, there are senior developers or people with experience of things going wrong who see a datetime problem and think, I will run away screaming, particularly if it involves time zones, which we will talk about later on. So both of those reactions are slightly unfortunate. You don't want to just assume everything will be fine and not pay attention, nor do you want to run away screaming and think, well, I'm never going to get it right, so I won't even try. And I definitely can't actually test this kind of thing in difficult situations. It is all feasible. So what I want is to encourage a more steady approach where you say, okay, this is hard. I will be able to get my head around it. I will be able to write code that will work reliably. The theme of PKIT is resilience this year, and we can write code that is resilient and doesn't need to fail for 2 hours of the year. My guess is if you've got datetime code, there's a significant chance, I'm not going to say it's wrong, but there's a significant chance that your code will behave unusually, maybe not critically badly, maybe just a bit surprisingly, for 2 hours a year in some of the world. So there are some places like India where there is no such thing as daylight saving time. India is permanently 5.5 hours ahead of UTC. And if you don't know what UTC is, you can sort of ignore this bit. I will go into it later on. No daylight saving time. Your code may well be fine there forever. In the US and Europe and many other places, but those are the two that I'm most aware of, there's daylight saving time where in the spring you go forward by an hour, a spring forward, and in the autumn we fall back by an hour. So I'll talk more about time zones later on, but during those 2 hours, or the hour of elapsed time and working with dates and times that are in the skipped hour, your code may behave oddly. And it can be tempting to say, that's fine, I will just hope that nothing happens at 2 in the morning or whenever your time zone skips. I don't think that's good enough, really. I think it's entirely feasible to get it right. And this is what today is about. So this is, I know I'm laboring this, but it's because it's the most important thing to take away from this talk, is that it's worth putting the effort in, getting a good mental model. It's all about getting a mental model and getting requirements. The actual coding tends to be relatively straightforward. If you're using the right tools and you've got the right mental model and you've got good requirements, the rest isn't simple, but it's relatively straightforward and it can be tested. So talking about the mental model, here is the list of concepts that I'll be talking about. Now, I'm aware that this is in a much smaller font than I usually use for slides, so I hope you're able to still read it. But this is all of the different, in fact, it's not even exhaustive, but it's the list of concepts in Noda Time and the java.time package. So first tip, if you're using .NET, things are better than they used to be. I would personally, from my very biased perspective, still encourage you to use Noda Time. And if you're using Java, definitely use the java.time package. You don't want to be dealing with Java util date, java.text.simple date format, etc. Those will be terrible. So both Noda Time and java.time have these concepts. So where calendar systems are called calendar system in Noda Time, it's chronology in Java. And that's a list of most of the most important concepts that we'll talk about today. I've just noticed there's a question in the chat. I'm going to come back to questions right at the end, because otherwise I will lose my place. If there is something absolutely urgent, then I may be able to take it, but to avoid distractions, I promise I'll answer all the questions at the end. But this is a bewildering set of concepts if you're used to, well, I just use Java util date and that's fine, or I just use system.datetime. And of course, in other platforms, there are platforms beyond Java and .NET, I'm very aware, and you may well recognize some of these and think, oh, I don't quite know how they fit. I really encourage you to think of all these concepts and see how they map onto the system that you're using. And if you're using the built-in date and time model for your platform, and there is a more comprehensive one available, you should at least consider, it depends on your code base and how much legacy code you've got that's hard to change, etc. But you should consider moving to one with more concepts. For some reason, dates and times tend to be modeled by people who think we should have as few concepts as possible and just reuse them everywhere. And that's a little bit like the way JavaScript used to be, with a 64-bit floating point number will be enough for everyone. We don't need integers. We don't need different sizes of floating points and integers. I think JavaScript now supports different numeric types. I'm not sure. I'm not a JavaScript developer. But as a C# developer and a Java developer, I'm very grateful for the presence of int and long and float and double to emphasize that things are different. When I'm using an integer, if I'm trying to index into an array, using a floating point value for that makes no sense at all. If I'm trying to record a temperature, well, then an integer probably isn't suitable for that. So different models work in different situations, and that's why we need more than one concept, where system.datetime isn't enough for everything. Let's have a look and dive into these concepts. So they're roughly split into two areas. One is machine time and one is civil time. And the first three concepts are going to be about machine time. So the sort of fundamental concept is an instant in time. Now, because we're not dealing with relativity, I'm going to say that an instant in time is universal. So imagine that you were on the phone with someone a bajillion miles away. I don't know how you're on the phone, but you're on the phone with an instantly fast connection. You don't know what planet they're on, what calendar system they're using, if they've got time zones, who knows? But if you're on the phone with them and one of you clicks your fingers, you can both agree on the instant in time that that finger click happened. Okay, so a typical usage for an instant is a timestamp in a database of when something happened, or a log entry. These are fine. They're usually in the past. It might be when you expect something to have happened by in the future as well. But often they're in the past at when something did actually happen. Now, the way we tend to represent instants internally in libraries like Noda Time and libraries like java.time, is using the idea of an epoch and the amount of time that has elapsed since the epoch or before the epoch. So, for example, most systems use what's called the Unix epoch, which started in 1970, January the 1st, midnight UTC. Now, I've used years and months and things, and they're irrelevant to the instant. That same instant could be expressed using the Julian calendar system or the Hebrew calendar system, etc. The Unix epoch itself would stay at that instant. So if you imagine that someone clapped their hands at the Unix epoch and then started measuring time, the way that internally things tend to be represented is the amount of time since that clap. And again, just to emphasize, that doesn't depend on calendar systems, that doesn't depend on time zones. 36 hours kind of elapsed since that epoch regardless of what time zone we're in. I would say the Unix epoch is the most common epoch, but it's not the only one. So in .NET, the system.datetime uses an epoch of January the 1st, 1 AD or 1 CE. So that's using what's called the proleptic Gregorian calendar, because the Gregorian calendar didn't exist in 1 AD. But if we imagine it went back in time, then that's what the default of date time is, or datetime.min value, and that's where everything's measured from. Another epoch is the epoch used for GUIDs, which is in 1753 or something like that, when the Julian calendar system was abandoned by Rome and they adopted the Gregorian calendar system. That was just chosen as a point in time by whoever designed GUIDs. It doesn't really matter. There's another one, the start of 1900 is used by Excel. It's important that within one system, we all agree what that epoch is going to be. It's pointless me saying, well, I will represent an epoch, an instant using Unix epoch, and I will represent an instant using the date time epoch. And then the representations need to be, you need to do conversions. So long as you're clear about what the epochs are, that's fine. And within any one system, you tend to use the same epoch. You may not even need to be aware of it. Within Noda Time, I have tried very hard to make it impossible to tell what epoch we're using internally. As it happens, we use the Unix epoch, but we could change to a different epoch. It would very slightly affect the range of valid dates, potentially, but you couldn't. There's no property that you can get that doesn't say relative to the Unix epoch, but is still relative to the Unix epoch. So that's instance in time. I'm not going to go into quite this much detail for every concept. But the next concept is duration. And we've already sort of covered this, because if I go back again to instant, this whole elapsed time thing, that the blue arrow, we're saying, well, an instant is represented internally by an amount of time that's happened since or before the epoch. And that is a duration. So a duration can be positive or negative. So it could be 3 hours or minus 3 hours. So minus 3 hours would be the duration used to represent something that happened just before the Unix epoch, for example. And they're not anchored at a particular point in time. So 3 hours is 3 hours, whether you were measuring the elapsed time since, a particular election, or since a disaster, or since the Unix epoch, or whatever it is. 3 hours is 3 hours is 3 hours. That's the same. Important to note that a duration can't be something like a month, because a duration has to be an absolutely fixed amount of elapsed time, regardless of calendar systems and time zones and things like that. We'll come on to the equivalent of duration with calendar systems later on, but it's something that's measurable scientifically. So if you want to start getting into vibrations of crystals or whatever, however the most accurate atomic clocks work, they are measuring durations. If you can't express the quantity you're talking about in terms of numbers of vibrations of a crystal, then it's not a duration. Okay, next comes an interval. So an interval is sort of derived from an instant and a duration. So it's a start time and an end time, both instants, and it has a duration between them. And whereas 3 hours was 3 hours was 3 hours, an interval of the start of one day for 2 hours and the start of another day for 2 hours, they are different intervals. Even if they have the same duration, because they have different start and end times, they are different. And those are all the concepts in machine time. Machine time is really quite straightforward, and arithmetic works fairly simply. You can add 3 hours and 2 hours and you can get 5 hours. and then you could subtract 1 hour from it and get 4 hours. And so duration arithmetic works simply. You can add a duration to an instant, take it away again, and you'll get back to the same instant. It's all nice and simple. It's only when humans get involved that things get really annoying. So, civil time. This is where cultures get involved and everything gets really tricky. The calendar system that I suspect most viewers are most familiar with is called the Gregorian calendar system. And it's quite similar to its predecessor, the Julian calendar system. It only changes in terms of which years are leap years around centuries. So if I remember rightly, and I could be wrong, the Julian calendar system, every 4 years is a leap year. In the Gregorian calendar system, every 4 years is a leap year, unless it's on a century. So like 1900 is not a leap year. But every 400 years, it is a leap year. So 2000 was a leap year because it was divisible by 4. Yes, it's divisible by 100, but it's also divisible by 400, so it is. So that's the difference between Gregorian and Julian, but they all use the same set of months: January, February, March, April, May, etc., etc. But there are completely different calendar systems around. So the Hebrew calendar system, various Islamic calendar systems, Japanese calendar systems, lots. One of the things you should think about when you're gathering requirements for your system, whatever system you're working on, is, do I need to work with multiple calendar systems? Do I need to work with anything other than the Gregorian calendar system? Because that's what's best supported by software. So whatever framework you're using is likely to make it particularly easy to work with the Gregorian calendar system compared with, say, the Hebrew calendar system. It's generally used by business around the world, but in personal lives, different people do use different calendar systems. And if you are writing a dating app, for example, you may well want to think, well, what am I going to do for people who want to arrange dates in calendar systems other than the Gregorian calendar? So work out your requirements. The simpler the requirements are, if you can get away with doing everything in the Gregorian calendar system, your life will be easier. But if you're forcing users to do something they don't want to do, then maybe you should take the hit and allow different calendars. So a calendar system, the point of a calendar system is to divide time into days, months, and years. That's basically it. If we ignore time zones, because they're difficult, we'll come back to those. You can imagine a timeline. So horizontal line, and you break it up into days, and you could have day 0, day 1, day 2, day 3, day 4, day 5, etc., from whatever calendar epoch you want. How do you label those days as year, month, and day? That's all a calendar system does. So it takes a number of days since some epoch and says, oh, right, well, day 3655 is year 9, December the 3rd, or whatever it would be. So if you are breaking dates, breaking the timeline into these year, month, day, using a calendar system, the next concept that we want to mention is a date, a local date in both java.time and Noda Time, but fundamentally a date. And a date is year, month, and day within a particular calendar system, or chronology in java.time. Some systems may not let you represent a date on its own. .NET only started doing so recently with its date-only type, and that's always in the Gregorian calendar system. So it's worth being aware of that kind of thing. If you have to work in a system that doesn't have a date, then you often have a date and time, and you say it must always be midnight. Causes some problems we might come on to later on, but that's an option. So a date is just a year, month, and a day in a particular calendar system. Now, how would you represent that internally? Well, there are lots of options. You might want to take the number of days since the epoch and store that. You might want to store an instant in time and assume that it's in UTC, or interpret it in UTC in the particular calendar. Lots of different options. As the library consumer, you probably shouldn't need to know and shouldn't rely on any particular representation. The only way in which it should make any difference is in terms of performance. So different representations internally can have very different performance characteristics. But fundamentally, a date would be something like when I was born. I was born on the 19th of June, 1976. That is a date in the Gregorian calendar system. It doesn't have a time zone attached to it. That's why it says local. It's just local to who knows where, but local to someone. And that's a date. Next is a time of day. And again, this is quite easy to understand. It's not in a particular time zone. That's why it's local time. It's just 9 a.m. So right now for me, it's 1:16 p.m. If you're in Romania, I believe it's 3:16 p.m. Each of us has a different local time, but it's local to us without specifying which time zone it's in. So just 1:16 or 3:16 p.m. One area to look into if you're trying to use local times is, does the system that you're using support the idea of 24 o'clock? Might sound a bit odd, can be really useful if you want to say, when is this shop open? Oh, well, it's open from 8 a.m. to 3 p.m. That's nice and easy. And usually you treat the closing time as an exclusive thing. So at 3 p.m. it has closed. That's fine. What about a shop that is open right into the night and may even go into the next day? Well, its opening time might be 8 p.m. till, you don't really want to have to say 11:59, 59.99999, and there's 1 nanosecond or whatever that theoretically it's closed for. So it's nice to have an exclusive bound that is 24 o'clock. Most libraries that I'm aware of don't support 24 o'clock as a local time because it makes all kinds of other things. It's great for that one use case. It's awful for various other use cases. So Noda Time doesn't support it. I don't think java.time supports it, but it's worth being aware that you may need to have your own small abstraction over local time, something like local time with 24 o'clock, that is a local time and a Boolean that says, well, if it's midnight, do I mean 00 or 2400? So to recap, in civil time, we've got calendar systems that break the timeline into days, local dates, and then within each local date, we have the time of day as a local time. So fairly obviously, it's useful to be able to represent the combination of a local date and a local time, and that's just a local date time. It's as simple as that, and that's what we use most of the time. So my local date time at the moment is 1:18 p.m. on the 4th of November 2022. It's as simple as that. You can see that I've been giving some variations of this talk for nearly 6 years now. I expect to potentially keep doing it for the next 10 years or so, until I might eventually get bored of doing it. But the concept itself is the one that if you ask most people in the street, what's the date and time, they will tell you a local date time, because that's what's useful for them. They won't say it's in, well, they won't say which calendar system it's in, because most people aren't even aware that there are multiple calendar systems, at least not most people in countries that just use the Gregorian. But they probably won't say in the London time zone or whichever time zone they're thinking about, because it's sort of implicit. It's in their context. It's a particular time of day. Okay, big deep breath. It's time for time zones. And looking at Florin's question around where we should handle time zone conversions, I will definitely come back to that. And without wishing to be too clickbaity, my answer may surprise you. So a time zone is essentially a function from instant to local date time. So it says for any instant in time, you can ask the time zone, what's the local date and time within that time zone? So if you ask the Europe-London time zone, what the, if you find the current instant, what's the local date time? It's 1:20 p.m. On the 4th of November 2022, assuming a Gregorian calendar system. I'm going to stop talking about calendar systems now. Everything in civil time needs a calendar system whenever you're talking about a date. Okay, I'll just take that as read from here on, given that we're into the complex stuff of time zones. So every single instant that you can imagine, so the whole timeline is always on, has one and exactly one local date time associated with it for any given time zone. And in theory, a time zone is associated with a region on Earth where that function always gives the same result. So everywhere in the UK, I think, you will get the same local date and time for the same instant wherever you are within the UK. And will do forever in the future and forever in the past. And if that ever becomes not true, because suppose Wales becomes independent and decides to change its clocks differently to England, then that would create a different time zone for Wales, because it will no longer be true that the time in Wales and the time in England is always the same. Okay, so a time zone is associated with a region on Earth where everyone's watches theoretically show the same time the whole time, forever. So a function from instant to local date time, that's unambiguous. That always gives exactly one answer. And we can demonstrate that with this graph that I've got here. So if the x-axis I've got as time, so that's instants in time, and local time, that's as in local date and time, it kind of goes up. The tricky bits are where the graph breaks. So I've got those two things in red. There's the spring forward. So on, I think it was on March the 7th, the UK skipped from 1 a.m. to 2 a.m. So you'd be coming up, 12:59:58, 12:59:59, 2 o'clock in the morning. We skip over the hour between 1 and 2. I don't know what happens in the Romanian time zone. Maybe you skip from 3 to 4. Maybe it's I think that's the case, but maybe it's at a different time. But you jump forward by an hour. Later, and as happened this last weekend, which I will refer to later on when answering Florin's question, we skip back. So in the UK, we went 1:59:59, or rather, sorry, 1:59:58, 1:59:59, 1 o'clock. So we went back from what would have been 2 o'clock to 1 o'clock. So everything between 1 o'clock and 2 o'clock happened twice. 1:15 in the morning happened twice. And it so happened there was one football match, don't know who it was against, but it was being played in some far-flung country, and it started at 1:30 in the morning, and half-time started at 1:15 in the morning, 45 minutes later, but after the clocks had gone back. So that's the sort of thing that ends up being a bit weird when you get into time zones. What I'm trying to say is the mapping from instant to local date and time is unambiguous and simple. If you try to map the reverse way, to say what instant is represented at 1:15 in the morning, once a year, that didn't exist because we skipped over it. Once a year, it will be, well, that happened twice. And you can see that if you imagine trying to find the time by taking a local time, so one point on the vertical axis of this graph, and then you go along to see where the line hits it. Well, in a spring forward, you may find that the line never hits it, and during a fall back, you'll find that it hits it twice. So that's the really tricky bit to work with or one of the tricky bits to work with in time zones is when things change. How does your code deal with it? What are your requirements? I'll move on and then come back to time zones. But the next concept is the date and time within a particular time zone. So I gave the example of local date time. My local date time is now 1:25 p.m. 4th of November 2022. My zoned date time is 1:25 p.m. 4th of November 2022, and with a UTC offset of 0. And I have to say that UTC offset of 0 because otherwise I don't necessarily know uniquely. So if I'd said, oh, well, it's I need to find out what date Sunday was. Sunday was the 30th of October. So if I said it's 1:30 in the morning on the 30th of October 2022 in the Europe-London time zone, well, that isn't unique. So I think most zone date time representations actually represent, they are uniquely associated with an instant in time, so they keep track of if things were ambiguous, did it happen, is it the first or the second occurrence? And if you try to construct a zone date time with a local date time that never happened, hopefully it will throw an exception or whatever the equivalent is on your platform. There is disagreement, including between me and some colleagues in Google, as to whether this is a useful concept or not. I think it is. Others may disagree. Be careful whenever you're thinking about your requirements. What are you going to store? How are you going to store it? If you've got zone date time, do you definitely know whether it's the first or second if it's ambiguous? What are you going to do if it's skipped? How are you deriving this information? Now, the next slide might look like it's the same as this. So it looks very different, but might seem to be representing the same information. It's really not. So date and time with an offset, so offset date time in both Joda time and Noda time, is a local date and time with a UTC offset. So I haven't really mentioned UTC much. UTC is a sort of the sea level of time zones, and it's how we it's how we communicate easily with each other. So the UK is currently on UTC +0. It was on UTC +1. What am I talking about? Romania is currently on UTC +2, and I suspect it was on UTC +3. Currently, the west coast of the US, so Los Angeles, for example, is on UTC -8, 8 hours behind UTC. And as of next week, it will be UTC -7 when their clocks go forward. So this -8 at the end here is saying that's where that would be an offset date time in Los Angeles. But really importantly, this does not include a time zone. Unfortunately, the ISO 8601, so this is the text I've got here is an ISO 8601 representation. And please, if you're communicating from machine to machine, so it's not for a user to read, but you need a textual representation of a date and time or an offset date time or whatever it is, please use ISO. Don't decide to use day, month, year or month, day, year with slashes or whatever. Use ISO. Everyone knows how to understand ISO and it's unambiguous. Whereas if you've got 3/4/2022, is that the 4th of March or the 3rd of April? Who can tell? So always use ISO, just as a separate tip, unrelated to offset dates and times. But the important thing is the ISO specification talks about this -8 here as the zone specifier or the zone indicator. It's not a time zone. Do you know how I can tell that it's not a time zone? I don't know from this what the time would be, what the UTC offset would be in a week's time from now. If we assume it's America, Los Angeles, then it would go to -7, but we can't necessarily assume that. It might be an offset date time from some time zone which sticks at UTC -8 for the whole year. if you ever need to predict what the local time will be at anything other than the given date and time, you need the time zone. You will not get anywhere with just the offset because it changes over time. That's the whole point of a time zone, is that the offset can change over time. So sometimes you'll see things like this and people will say that's the time zone. It's not a time zone, it's the offset. And often that's all you need. You know, this is a perfectly useful concept, which is why we model it in Noda Time and java.time. And it's often used in headers and things like that. It does accurately convey, or precisely convey, a local date and time and an instant in time. So the local date time, you can just ignore the offset bit and say, well, that was 9 o'clock in the morning somewhere. And you can say, but it's in UTC -8. So it is the instant in time of 2017, January 19th, 5 p.m. UTC. That's useful. You can compare that with other things. That's really helpful. You can see which happened first. It doesn't tell you what the local date time would be 10 minutes later, because it could change based on the time zone. Okay, I think our final concept now, you'll be pleased to hear, is the idea of a period. So ages ago, when I was talking about machine time, we talked about durations. And a duration was an elapsed amount of time, like 3 seconds or 5 hours or 10 minutes. A period can be any of those things, but it can also be something that might change over time. So how long is 1 month? Well, it's usually 28 days or maybe 29 days or maybe 30 days or maybe 31 days, even assuming the Gregorian calendar system. So that's not a fixed amount of time. So we can't represent 1 month as a duration, but it's still useful. A lot of business requirements will be in terms of months. So it wouldn't be useful for sort of the deadline for an RPC. That should be expressed almost always as a duration. But how long a customer has to return some goods, for example, would very often be 3 months or 6 months, something like that. Now, the tricky bit is calendars don't really play nicely with periods. Arithmetic just doesn't work nicely. What is 1 month later than January the 30th? Maybe February the 28th, assuming a non-leap year. In a leap year, maybe February 29th. Or maybe the date and time system you're working with will say, oh, well, I'll move it forward to March the 1st. You need to know this. If you're doing anything with period arithmetic, calendar arithmetic, you need to know 2 things. One is what your requirements are, and one is how the system, the platform that you're using, behaves by default. Because if it doesn't do what you want, you can always adapt. That's fine. Might take a bit more code, but it's doable. But if you don't know what it does to start with, you can't possibly know whether your code is correct or not. So if you have a requirement from your product manager or whoever of, a customer must be able to return an item if it's within 6 months of when they bought it. You probably want to think about time zones as well. If they're a UK customer, but they bought something from Romania, well, which time zone, what does 6 months from the sale date mean? Is it 6 months in their local time or in Romanian local time? Who can tell? You need requirements. But also, if they bought something on what would it be? I guess August the 30th, and then you add 6 months to that, and assuming I've got things right, I think I have, that would be February the 30th. Well, that doesn't exist. So does it actually extend to March the 1st, or is it the last day in February? Things like that. You need to be careful of that sort of requirement. The more precisely you can get to the requirements, with ideally lots of examples, those examples will make great unit tests. So ask your product manager for lots of examples. Give him or her, sorry, mustn't make assumptions. Give your product manager some examples saying, okay, so if someone bought it on this date, when's the last date they can return it? And force them to go through those difficult corner cases. And once you've got those examples written down as acceptance criteria, however you decide to run your project, you can then write the tests. And then you don't even need to know beforehand what the system will do by default. You can make sure you've written all the tests, write the simplest possible code that might work, see what happens. If you've got enough corner case tests, that's okay. Personally, I would actually find out what the system does in terms of calendar arithmetic first, but with enough tests, it's not too bad. So those are all the concepts, and I will come on to onto questions very soon. I'm aware that I started 10 minutes early, so I should probably try to finish 10 minutes early, but we might have a bit of leeway there in this particular case. But let's have a look at some tips and tricks and things not to do. And this is where actually I will probably cover Florin's question along the way. So my first big tip, and if you want to take away one concrete thing you could start doing today if you're not already doing it, is to inject a clock. And by inject, I mean like dependency injection. So Noda Time and java.time already have interfaces. It's just called clock, java.time.clock for Java, or iClock in Noda Time. And the idea is a clock is something that will tell you the current time. In Noda Time, it actually tells you the current instant, and that's all it will tell you. There's a zoned clock that has a calendar system and a time zone, so it can tell you the current local date time or zoned date time or local date or local time. But fundamentally, a clock is just something that knows the current instant in time. And use that everywhere. So if you are using system.currentTime millis, or in .NET datetime.now or datetime.utc now, your code is really hard to test. And if you're not writing any tests, that's fine. I would encourage you to write tests. And when you write tests, you will want to be able to say, oh, well, what happens if the current date time is a particular, if we're about to go into a daylight saving time change, or what happens if we've been through a daylight saving time change and fallen back to a different, an earlier local date and time. It's much easier to do if you inject a clock. Also inject time zones. I tend to try to avoid anything that refers to the system time zone, unless it's for, if you're writing a local application, so it's running on a desktop somewhere, and you want to show the user the time something happened, then using the system time zone is probably fine for that. But be explicit about it, because then later on, if you ever want to adapt that same bit of code, reuse the code for something that's in a web server, then you can say, hey, this is the time zone I mean this time, because the system time zone is kind of irrelevant for a web server, and you shouldn't really refer to it. You want the user's time zone probably, or maybe the company's time zone in some particular cases. So inject clock. If you're working on a system that doesn't have one, it's really, really, really easy to do. You can create your own interface that has get me the current instant in time in whatever name would make most sense for the platform that you're using. So if your platform doesn't have instant as a concept, but does have timestamp, then get current timestamp would be a fine method or function name. Have that as an abstract class and interface, again, whatever is appropriate for your platform. And then you can have a singleton. I'm not generally a fan of singletons, but your system clock really is a natural singleton. A system clock singleton implementation that then refers to datetime.utc now, or system.getCurrentTime millis, whatever it is. But then you can create other implementations that allow you to say, let's just imagine that it's 2035, or let's imagine it's 2010, whatever it is. And I tend to call that a fake clock. And if you're using nodatime.testing, you can just use the, if you're using Noda Time, you can use the nodatime.testing package to use a fake clock that I provide you with, but you can easily, if you're writing your own system, this is really trivial code, but it makes your code so much more testable. So inject a clock. Other things that you should be thinking about, you need to work out for every bit of your requirements document, anytime someone says you should store the time that this happened or the time of an event in the future or whatever it is, think, well, what am I actually storing here? If it's the instant at which something happened, then that's an instant. If it's something that the user has typed in, that's probably a local date time or a zoned date time or a local time or a local date. Those aren't instants. So be aware, are we dealing with something that's kind of user oriented, and it may not be something they've entered, it may be something derived from some other data, but if it's user oriented, then it's probably a civil time. So with a calendar system, if it's just a timestamp or something like the duration for a deadline for an RPC, that is going to be in machine time. So work out which concept and which timeline applies for every concept in your system. Work out how you'll store it, bearing in mind that most databases don't have this nice array of concepts, and I'm afraid I can't talk much to databases, but I'm aware that they're painful to use in this front. Be aware of calendars and cultures. Do you need multiple calendar systems? Do you need multiple time zones? Maybe you don't need a time zone at all if there's no user data that depends on the time zone. Maybe everything can be in machine time. If you've got multiple time zones, how are you going to work those out? If you're representing anything textually, ideally, if you're asking a user to specify a date, then use a calendar picker or whatever. And if you're presenting information to a user, then you probably want to use their culture for presenting the time, date and time to them. Probably not great to use ISO 8601 for that, unless they're a developer. If they're a developer, they will probably be grateful that they don't need to worry about whether their system thought they were American or not. So is it month, day, year, or year, month, or day, month, year? But consider that textual representation. Also consider, if you're logging a date and time, who's going to read those logs? You're then talking to developers. I would personally use ISO for that. So there are different textual representations for end users who aren't developers, diagnostic tools for developers, and machine-to-machine communication in JSON or YAML or whatever it is. That should almost always be ISO. I've mentioned zone and clock dependencies. So those are the big things to think about. Now, a few tricky areas. One is, if you've asked the user for a date and time, and they've told you, well, 1:35 in the morning on this particular date, what do you want to do if that is ambiguous or it didn't exist? Do you want to silently pick, well, I'll use the second of those occurrences, or I'll assume they meant 2:35 a.m. or 2 a.m. or 1 a.m. Or not 1, 12:59, if it doesn't exist? Who knows? That's up to you to discuss with your product manager. I'll come on to the really tricky bit in a minute. If you are working on a platform that doesn't have a good framework, or doesn't, or you've decided not to use it, so you're going to use system.datetime instead of Noda Time, okay, I can understand. So obviously the bias bit in me says you should definitely use Noda Time. There are reasons not to use Noda Time. Whether they're valid or not is not really for me to say, but if your company cannot use open source software, it can only use what Microsoft provides, far be it from me to say that that's the wrong thing to do. If you are forced to use a relatively poor framework, and I mean poor in terms of it may well work absolutely correctly with no bugs, but it doesn't allow you to represent different concepts with different types, then either wrap things in your own types, maybe. That's also an anti-pattern. You don't want to start building your own date and time library unless you really are in the business of building a date and time library. Building it as part of building another product, probably not a great idea. Or make sure everything is really clearly documented and named. So you say, this is a date time offset that always has an offset of 0 and should be regarded as effectively UTC, for example. I will just come to one of the questions now from Paul saying, I don't develop in Java, but will there ever be a Noda Time version for Java? That's a really, I'm not mocking you at all, but it's a really funny question, because Noda Time came from Java, from Joda Time. Before the java.time library, there was a very, very well-regarded library called Joda Time for probably decades. I'm sure at least 10 years before java.time came along. And it looks very, very much like java.time, have many of the same people behind it. Stephen Colborn in particular, I don't think he started Joda Time, but he became one of the primary maintainers and then worked on JSR 13, I think, which became java.time, or sorry, JSR 3.10. So java.time and Noda Time both sort of derive from Joda Time. So I definitely wouldn't be porting Noda Time to Java, partly because they're not quite the same, and there are some decisions that I think I personally prefer in Noda Time, but java.time does a really good job in general. And it does a sufficiently good job that I'd never get people to decide to use my JNoda Time or whatever. Whereas Noda Time in .NET is sufficiently better than what you get out of the box, even now that we've got date only and time only, that for many people it's worth adopting. It's by no means, it's not nearly as popular as Joda Time used to be. So the java.util.date class was so awful in Java. Everyone had horrible problems in Java. So Joda Time was adopted really quickly by loads of people. If you were doing anything serious with dates and times in Java, you would use Joda Time because it was the place to be before java.time came along. And then people were just encouraged to update. In .NET, system.datetime and system.datetime offset are sufficiently easy to use that your code will work most of the time. It doesn't have, my philosophy in Noda Time is to really strongly encourage you, if there's a question to be asked, I will make you express the answer. I don't take anything for granted, unless I absolutely have to for compatibility reasons. So when you construct a local date pattern, for example, to format something in Noda Time, you have to say, I want the invariant culture, or I want the current culture, or a specific culture. I do use the current culture if you're using iFormat provider, just because that's what I'm told to. But in general, my philosophy is make the user express their decision. So you can't accidentally get something that says, I will ignore skipped times and just use the time afterwards. You have to say, well, I'm doing this time zone conversion leniently, and that means these things. Whereas time zone info will hide the question from you, which means you don't know what you need to be thinking about. I will come back to the other bits, the other questions. So I mentioned the really tricky bit with the incomplete information, and 1:35 in the morning, if you already know at the time when you're asking the user that 1:35 didn't exist, then it may be easy enough to say, oh no, you've got to tell me. What happens if the rules change? And I don't mean, if like the rule, like the offset changed last weekend, but if the rule itself changes because Europe decides not to do daylight savings anymore, for example, so something that was previously valid becomes invalid, that's really hard to work out. I will plow on. I see Julia is present. Have I still got a few minutes to go through a few more bits, Julia?
We have a few minutes. At 4 we start another track, so we can wrap it up until 5 minutes to 4.
Okay,
And then I will ask you something, because I'm just showing this
right.
book can get to one of you who are watching and asking question. Will be back with all the details in just a few minutes. So 5 more minutes and then we wrap it up.
Okay, I will get everywhere in 5 minutes. So some gotchas, and this comes back to Florin's question of where should we handle time zone conversions? And there is this myth that it's fine if you store UTC, you won't have any time zone issues. And I had this just this last weekend. I charged my electric car. I can tell my charger only charged between 12:30 in the morning and 4:30 in the morning, because that's when electricity is cheap for me. And I was interested to see on that Sunday, would it give me 5 hours of charging or only 4? And I mentioned this on Twitter, and lots of people very helpfully said, oh, well, modern systems convert everything to UTC. That's the way to deal with dates and times. And enough people said this that it's like, no, that's really not the right way to deal with this particular situation. Storing UTC can be fine for past timestamps. It's not the right thing to do here. It's not the right thing to do for user specified dates and times in the future. If you search for storing UTC is not a silver bullet, you'll find I've got a blog post that goes into far more details. You can see some other anti-patterns and things that you shouldn't do. Do not roll your own date and time framework, full framework, unless you absolutely have to. You can create wrappers for small concepts and use another system to do most of the hard work. That's fine. And never use time zone abbreviations like CST unless you're just displaying it to a user. If you ever have to parse a time zone abbreviation, be aware they're ambiguous. Okay, I'm going to go over to the questions now. So hopefully I've talked to Florin's question. I would say in detail, if the user is specifying a date and time, that's what should be sent to the server. And that's probably what the server should store as well, because certainly if it's anything in the future, you cannot predict accurately what that instant will be. Store what the user has sent. And even if you do other calculations for optimization, if you always remember what they told you, then you can't lose any information. You may not have asked everything that you need to, but at least you'll have what they told you. If you're presenting something to the user, it's fine to do and you know which time zone they're in, it's fine to do that conversion on the back end, send the front end a pre-rendered thing, that's fine, or do it on the front end. I'm not a web developer, but both of those seem fine to me. Right, going through, can you represent date only using Noda Time? Yes, use the local date type. That's a dead easy question to answer. Yeah, I have every concept that I talked about in the talk is within Noda Time because I think it's important. And yes, I agree. It's a pain that date time doesn't have that for you. How would I approach using Sol coordinated time if I started designing an application for other planets? I would probably want to work with a different framework that is designed for that system. I'm not kidding when there's a newish set of date time libraries for JavaScript. And one of the questions was, should we try to support Mars time? It's like, no, we don't have any business use cases for that at the moment. Who knows what you'll actually need to do? You can't start designing a library to cope with use cases you don't know about. So I would say when I had to design an application that worked on multiple planets, I would get very concrete requirements in as much detail as possible. Then I would start planning what I want the frameworks to look like. And I think finally, what do I think about the new date only and time only? They're great. You may dislike the names. The names had to fit in with legacy systems, etc. But the fact that they exist is a very good thing. And eventually, if Microsoft keeps on evolving .NET, maybe I can retire from maintaining Noda Time at one point.
And we have one more question, and I will stop the questions here because we will start we will go in tracks. So one more question, and don't forget that you can also go in the lounge and meet the people and have chat there. So please, John, one more answer, and then we will pick the winners.
Right. So the one that I'll speak to, I'll actually do two because one is really simple. If you find me on Twitter, you can find or read my blog. That gives a good answer to how you should deal with the charging car one. And I've now just lost the chat. The critical information to be provided by business technical analysts is anything. Think of as many different scenarios as you can. Imagine people living in different places. So imagine you're ordering from the UK, but shipping to Romania, and it's being shipped from China or something. What are the time zones involved, and how does that change what questions you need to ask?
And there is one more question, because Mihai wrote when I said I'm stopping the question.
That's about the car charging one.
Okay,
that's
great.
The one.
If
you read my blog, so codeblog.jonskeet.uk, I can put it in the chat here.
Yes, please. And meanwhile, I will show this book, Software Mistakes and Trade-offs. We have 3 books, 3 exemplars, from you for three questions. What are your choices, John, for the winners? And the winners are the drums. You're choosing from your questions.
Right. So Florin's question, certainly, about where should we choose, where should we convert time zones?
Great.
Christian's question about designing applications for other planets, and Adelina's question about what's the critical information.
Great. Thank you very much. Congratulations for the winners. Yes, and a lot of applauses. And thank you for you, John, for this presentation. Thank you for being with us. Thank you, everyone. See you in tracks in 3 minutes. Thank you.
Bye,
let's have a great day. Bye-bye.
Bye.